Hello to everyone. Welcome to today's live. It's very interesting day today. So finally, my voice is much better. Excuse me if I'm coughing a little bit, but I'm feeling much better. So I have started a new training session, which I believe will help a lot of newcomers in the industry. Probably you will be, let's say, from different kind of sectors. And in recent years, I have seen also people from IT watching the videos, and they're also benefiting from this kind of knowledge. in today, in today video and training sessions, which we will start, and we will have also some examples on the board. I will share also images that I have collected, and we will deep dive a little bit about the heat plate exchangers. In the first view, it's a very easy equipment to handle. There is not that much pieces involved, but if you will see it as a wall, let's say equipment, you start to realize quickly, but that there is more than that. That there is more designs, there is more details on it, and it has a specific reason that is present there. So, from the viewpoint of engineering, what an engineer uh, should look for is that the details he's not missing of. Such details can be, let's say, design, such details can be also placement, proper positioning of the equipment. So there's a lot of different kind of details that are playing a role. I have a lot of coffee with me, so let's deep dive and start. Let's see what we will share. One moment, please. And we will share not entire screen window. Let me see what we can share. So I will open a window. Let me see. And better, yes, I will share exactly the wall unit. The first image that you will see, it will be the wall unit completely. Let's zoom it. Let's zoom it a little bit. Okay, let me see. Okay, that is it. Maybe it's not so much clear, but you can spot quickly some of the biggest details of that. So we have the stable plate, which is here, which is also bolted in the front. When you're doing the overhauling and the cleaning, let's say, process, it's better this part to stay as much as in position, because this will be your guidance for the assembly itself, and also the part which is the guide bar, and also the holding bar on the top. So each and every case, each and every part here has a specific role to accomplish. So from the plates, for the pressure plate at the back and the plates in inner, we have the wall assembly with the studs, which is specifically protected. Some of heat plate exchangers are not provide any information on the plate here. So such information can be Lisa, Лиза, я не могу так снимать это видео. Пожалуйста. So these plates will show the total distance and the measurement of the plates. It will show the capacity of the heat plate exchanger. It will show the wall capacity and also the heat exchange um, kilojoules, let's say, per cubes or kilojoules per hour. It will have specific um, identification. So really take a look of the specs, what is on the plate, and then you are much able to understand, okay, what is provided by the manufacturer and what you have to look for in the manual itself. A very important thing is that you work in such way that you identify all the spare parts quickly, and you store also your spare parts properly. What I have seen from the experience that a lot of this kind of rubber it's not properly stored. So what we mean by storing, properly placed in position as spare parts. If you're looking, let's say, also to our industry and many industries, this is one of the biggest issues of storing spare parts properly. I have been in many vessels. I have been in many different, um, let's say, parts of industries, from let's say refinery, looking from the terminals. This is one of the biggest problem that these industries are having. It's proper positioning, proper storage of the spare parts. Because spare parts, it's not just put it there and leave it. It will rust. It will have issues. So you cannot put this assembly back on the, let's say, in operation just by taking that and put it. No, it will for sure will have some effect in the unit. And this is, I believe, yes, this is one of the things that for sure will impact the quality of the media that you will operate with in some environments. It should be really fine, looking from the point of contamination, all the things. So the storage of such equipment plays a huge role, and also how it will impact the internal parts also, that it, it should be given proper attention. So all the parts should be also visual examined, let's say, the surfaces, as you put it, if some o-rings is turned or not. So you have to give a proper attention in each and every detail, because as I have seen, every detail play a really huge role on the overall performance, the application of the maintenance itself, and then how long this um, maintenance will keep up for, let's say, until the next service time. So, and this shows also that this kind of specific jobs, wherever you're doing, pumps, valves, let's say um, steam reducers, wherever you're working, boilers, you have to give attention both from the cleanliness of the work that you are performing, from the application of the parts that you are combining and you are assembly, how good your assembly is, and also very important thing that I have seen, it is the testing for the quality before set it on the unit for further operation, because this kind of heat exchanger can play a huge role, let's say, from cooling your engine, um, or let's say heating something. So if it's not working properly, or you have extensive leakages, this can have an ongoing effect on the quality of the work of what you are going to do. So that means, if, for example, you are heating some chemical or some diesel and it has leakage internally within the plates, that means you have to disassemble back again. You have to find the cause, why and for what reason it is happening, and then your job and your time is doubled additionally. And this is the reason why you have to be prepared of doing a quality job from the beginning, to avoid to repeat the mistakes and to drive you, let's say, for unlimited hours until you find where the issue is. Okay, so this is about the assembly. This is about the assembly. All in each individual parts here have a specific role. Okay, every on that, it is designed to execute a specific function, and as well the assembly, it has to perform for what it is designed for, transfer the heat from one media to another. Let's look a little bit. Let's look a little bit on how the flow in these plates are happening. If we are, one moment, if we are, let's say, exploit the cooler and we open the plates between them, what we see the flow diagram. We see how the flow between the plates are going. And we see that we have a different flow. And this is why this reason is selected. Excuse me, because this is the most efficient way to transfer the heat from one media to another. The flow is exactly as it's shown. The entrance of the cold fluid is from here, and then it goes down from each plate, and the cold fluid outlet is from here. The hot liquid inlet is from here, and the hot outlet is from here, from the top. So you can see that if you are looking, what is the, let's say, area that is used by this plate, it is exactly this one. You can take the contour of this one and going down here, from here and from here. So this is the area of the plate that is being used. Okay, this is the plate of the area. So you can see also that the other plate, it is going opposite. So it enters here and it goes here. So it's exactly opposite. It's a mirror. And you can see from one side it's open, from the other side it's closed. Then it's open, it's closed. Open, close. So you have to give this attention to see how, when you dismantle the first plates can be different. You have to give attention because there is varieties of how the plates are positioned. So for example, maybe you can have close both of them at the beginning, or you have also some plates which is closed on the top. So it redirects the flow in the different direction. Give that attention. A very good practice it is to take a picture if you don't remember, or by mobile or by a photograph machine. For the first time, yes, it's better to take pictures because you can memorize it sometimes, but you can instantly forget it because you are thinking a lot of things in your mind. So take pictures, take also the manual, take also the book that it shows also the position of the plates, how the plates are going. And for sure, in the next video, I will share you more details how to read this manual, how to read this documentation in order to see how the plates are positioned in the installation. So, and let's see another image which is similar. Let's see another image which is similar. Is this one? And you can see the flow principle, yes. It is exactly as you see it. It is exactly like that. Another image, maybe it's more, let's say, more precisely shown, is this one. Maybe it's much better for viewing. Is this one here. So you have a 3D, let's say, representation. Also, very important thing to remember, how you tight your cooler, it depends from the size. Smaller size have different tightening sequence. They have less stats. Smaller will have, let's say, for example, 1, 2, 3, 4, 5, 6 stats here in the front. But much bigger heat plate exchangers will have much higher a number of the studs. So probably they will have studs here on the top, in the bottom. So the sequence of tightening also changes. And very important is that the people that are tightening and release it also are doing the same equal amounts of turns. Because for any reason you do not like this plate here, the pressure plate that pressures the stack of the plates in the position, you do not like to bend it for any reason, because by bending it, it can break also, it can bend, and also then if you bend this plate, yes, you have to order um, the plate or even the wall heat plate exchanger. And for sure, for any reason, you do not like this happen on board a vessel or a huge unit that is actually needed this kind of heat exchanger. It's really huge damage. So you have to remember that this plate has to stay as vertical as possible, and also um, the how fast you are going, no, not how fast, excuse me for that, not how fast, how much difference you can have from the top stats and to the bottom is also defined in the manuals. It depends from the manufacturer. It depends also um, the knowledge that manufacturer have. It has to be specific. No more um 10 millimeters, something like that. The difference between the top and the bottom stats. In order to avoid all that damages. So I'll share you another image. Let's close that. I will share you also this image, which shows how much different types of the heat plate exchangers are. So you can see that there is different varieties of the plates. And also some of them can be selected for different liquids, different media, but this is a preferable type of heat plate exchangers for the reason that they have much less um, space occupied. This is the main reason why this kind of equipment is used. And also, a very important thing is that this kind of heat plate exchangers are able to expand. What I mean, simply, you just add more plates to that, or you reduce the plates, and you are able to achieve the temperature that you are, let's say, requesting. So also the material can change as well. It can go, let's say, from stainless steel, titanium, nickel, aluminum, incolloy, Hestel alloy, monel. So it can be different kind of combination, but this is some of the examples that can be found in the industrial application. This is the plates. And let me show you another image. Let me see. I have prepared this image, which also shows you how the flow, it really shows you the flow in the macro level, how the flow is going of the hot liquid and the cold liquid. So they have different opposite flow. And one of the important things that we have to refer that when you have fouling here and you have build-up of the sludges, so the heat exchanger capacity reduced dramatically. And you have also additional increase of differential pressure. That means your pump has to work much harder in order to pump the fluid through the heat plate exchanger. So what happens, you consume much more power in order to pump the same capacity of the water, because the pump have a back pressure, and also you do not have the same efficient cooling effect or heating effect on your heat plate exchangers. And then another result that is happening as well, it is the plate degradation. So the plates are overheated, they are affected by corrosion as well, and a really special care should be done also by proper timing of cleaning, proper agents of cleaning. So each and every application that you will use the plates, let's say for example in food industry, in let's say oil industry, in shipping industry, in all the industries, you will have a different cleaning agents, because basically you have different products flowing in your uh, heat plate exchangers. And very important thing is that you have a proper monitoring um, management system in order to set a preventive maintenance in the such level that you keep your heat plate exchangers far away from the corrosion effect. Because I will share you a photo, a real photo that I have seen many times. And this shows also that the heat plate exchangers was not um, overhauled when required. So you can see, one moment, I will send it directly from my mobile to here, and I will show you what it means in real live image. Let me show you if things are not really taken in the account. So you can see here that you have a huge corrosion in the plate, the support plate, which is the front plate that I have shown you at the beginning, which is bolted down. It is steady, but you can see that we have a really prolonged time between the maintenance and also the media, and also not proper attention given when required. Probably also it's other factors as well. It's factors that are affecting the corrosion itself. It can be damage, let's say, of the paint as well. And then if the paint is damaged, then it goes also to a deeper corrosion, such as, let's say, rust and other things. So it depends down. And then what is happening? You would like to put back your plates or set up, and your plates does not touch properly, or it's not positioned as required. Luckily here, in this case, the sealing is being done here. The surface is still to be able, let's say, to seal between here, because this is the place which will be used for. But for sure, at some point, it will require a much more better attention. In similar cases that we have seen a much bigger heat plate, we have even, let's say, deep fittings on the body, and we have to apply, let's say, plastic steel. We have to use sand, dust, paper in order to make it, let's say, repair it back in its initial condition. So you can see here we have also blistering as well. So the paint poop ups. It depends, yes, from a lot of factors. But in this condition, okay, you can still use it, but in the next maintenance, it for sure it will need some, let's say, repair, which will be much more time consuming. So you have to take in account when you're overhauling things that it's not always the job itself. It's not always the work that will be done, let's say, from the view of point by changing the plates, cleaning the plates. It's also what you will find in the between, and always calculate your time for maintenance a little bit more, let's say 1 hour, 1.5 hour, 2 hours more from what is required, because your equipment is not new anymore. It's not in, let's say, in condition that it does not. It's completely different, and also it's completely different when you have it on the factory, when everything is new. Everything it's new, the plates is new. It is different conditions in different situations. So that's why it's so much important that you keep the same approach, that treating each and every part as it is required, this precision that it's necessary. So that is it, one of the images that I would like to share with you. Let's see. We saw, yes, how the heat is transferred through, and also now we will see the leakage indication of the O-rings. So we will see the design and what is the difference in the design, and how you will able, if you have any leakages. So in case you have a rubber which is wrapped here, let's say, for example, you have a seawater coming from here, you will have indications from this kind of passages, because these passages are open, it's like that, and it's available to give you the indication that something is wrong with your ceiling. And specifically, it shows that you have damage of your part somewhere here. So if we cut here, you have the liquid flow similar as it's seen here, and it will be visible here. So let's say, for example, if you have oil passing from this plate, you will know exactly, yes, okay, we have there a damage, and this is the reason why it comes oil. If, for example, you have water side here and you have broken this part here, as we can see in this image, you have water flowing from the indicating points. So how these indicating points looks like closely. Let's give a close look to that. Let's give a close look to that. Okay. Let's give a real view. So you can see here, I will zoom it a little bit better. So this is how they looks like. Open. So from here, the liquid is passing. And from here. And from here also. Directly. So if you have a cut it here or here, you will have indication, or even here. For sure, if you have your O-ring here, you will have leakage here directly. And also if you have here a cut, the oil or the water, whatever is it, it will be here, the indication. Also another thing that we have to give a reference about is that we have clip-on O-rings. What this means? That means that you have some parts of the rubber which needs to be inserted in specific locations, as we see here. So it's exactly a T which goes behind the plate and grab and keep the O-ring in the position. You can see we have clip on here, we have here, we have here, we have here, we have here. So it clips on and it gives a support to the O-ring to stay in the position. And this is the reason why we have it. Also, another good point is that when you are removing the O-rings and you do not remember how the O-rings are going, let me show you if I can find that picture. Let me see. Okay, if you don't know how the O-rings are going, when you remove them, the O-rings are leaving a clean space below it. So much probably you will see the pattern that is printed on the plates. So here will be dirty, let's say dirty, and where the O-ring was laying down, you will see a much cleaner space, or you will understand, yes, this is the position of it. Another thing that is very important to share is that each individual plate has a number. Will be here in this section, in this section, and when you will get the manual, you are 100% are able to identify which plates are going in which position. So you have this document on board. You have, because it indicates the sequence of the plates, how many plates, what kind of plates they are, and it has a identification number. The flow of the liquid coming from here enters, passing from this structure. You can see the structure is specifically designed to create a turbulent effect. So we need this turbulent flow in order to have as much as possible maximize a transfer of the heat from one media to another. And you can see also, just imagine this, a similar plate from the other side. The fluid is passing between them and give um, heating, let's say, capacity that is required. Also, a very important thing to say is that the sealing surface of these O-rings are always visible from this side, and also this small pattern you can see in the middle. This is actually where the surface will be seated. If you turn it on the opposite side, it is completely flat. That means you are using the wrong side of the O-ring. This is the position that is being placed, and this is where the O. Okay, let's look another image. Let's look how the O-rings are when removed. Okay, that is it. And the O-rings should be stored like this position. So they should lay down. They should not be twisted. They should not be put any weight on them. They should be normally open, so it will not have a permanent um, deformation from the long storage. And also they should not be exposed to X-ray. It should not be exposed to hot temperatures. That all plays a role for the longevity of the O-rings. For sure, it is good to have this kind of O-rings in order to replace, but also remember that if you have the availability, let's say, and you know that, okay, in 5 days or 10 days you are doing overhauling and you have the availability from the manufacturer, it's better directly get them from the manufacturer for your maintenance rather than store them and keep them for years and years and years without any usage. And then you just put them after, let's say, 10-15 years, and the O-rings are already not properly stored, degraded, or something else, whatever. So also, very important to say that the stack itself, specific degree of tightening, and it's a measurable data, let's say it's 255 millimeters or 300 millimeters, which is the normal tightening. And also it can have also a maximum tightening. So it can have a maximum point until where you can tighten, which is critical. For sure, it is critical. You should give attention to not overcome that, because you will stress the plates a lot, you will press them more than required, and for sure the plates can crack. The support plate can, the pressure plate, as we see here, it is, let me see, it is the inspection cover. It can be bent, it can broke. And let's see, this is the inspection plate, this one can broke. And also some manufacturer gives also a proper torque. If you use, let's say, torque range, the speed of the range that will be used, the newtometers that will be used, so it will not be exceeded. It's also very important, because if you exceed it and you have a much more tension here than here, that means your power distribution, your tightening is not properly distributed from all the stack of the plates. Also, very important thing is that you keep all the parts, all the let's say pieces, very very clean condition. And why I'm saying that, because this is the movable, the roller assembly. It will play also how your disc will be uh, stuck in the position, how they will be attached in the position. So you need both the guide bar in the bottom to be clean, 100% clean. You do not need any debris, and also the carrying bar should be clean because it will help you to move the discs much easier in the position, in the final position. And very good practice is that when you're moving your plates in the position, you are fixing them, one person they keeping them in their resting position, in the file position, and the next plates are moving. What I have also understand that the more people involved in this kind of process, by cleaning, let's say, the stats properly, because also the cleanliness plays a huge role how the tightening torque will be distributed. Because if you have, let's say, a bolt which is not cleaned and another bolt which is cleaned, the difference of the pressure that will be distributed also will be different, my friends. All has a huge impact. So what that means, one person is holding the plates, another person is changing the O-rings. It gives the attention that nothing is bent, that the O-rings are in position, that, let's say, tightening bolts are clean, the washers, the nuts, everything rolled properly and turning. And we do only what is required. We do not add additional job. And that's why I said that the fixed cover here, it should not be moved for any reason. If only it has some, let's say, huge problem, some misalignment, or some problem that you need to replace, this is the only thing that you are doing in removing. Another thing that when you clean, you use only soft brushes that you will not damage the plates, because what is happening, and I will share that with you, that if you scratch the surface of the plates with a steel wire, it will create a surface, a yes, much rougher surface, and this surface will be dirty much more faster because the roughness will trap the debris, will attract, um, let's say, the corrosion itself. It will be much more faster because simply you remove the protection layer of the initial metal. And it's also the starting point for the bubbles. The bubbles are formed when we have a structural irregularities of our material. And as you know, since the bubble is created in the heat plate exchangers, what is happening? It is air. Air is a good insulator, and that means that you will not have the same transfer of the heat from your heat plate exchanger. That means that basically the only best way is to use soft brushes, plastic brushes, which does not make damage to the plate, but just only remove the dirty. And very, very important is that you always consult your manufacturer of what media you should use for cleaning. Because if you use inappropriate cleaning, it can also damage the metal, it can corrode the metal, it can change the metal structure as well, it can affect how the metal will be degraded, let's say, in the next, let's say, years of the usage. So there is a lot of things, yes, that we have to care for. But one of the most important things, if you are installing let's say, such equipment for the first time in an installation, it is the carriage. It is the carriage of the product, the transportation, because you need a product that's transported properly through, let's say, from the factory to your installation. And you need to make sure that it's not damaged. And in such a way that able later on to take it, install it properly, and keep it in good condition by monitoring properly. How to monitoring it? It is another chapter. It is by pressure gauges, by temperature monitoring, because you have the inlet ports, you have the inlet temperatures, the outlet temperatures, the inlet pressure, the outlet pressure. So then you have to have a precise system which is monitoring your heat plate exchangers. And directly, let's say from the engineering viewpoint, and for the owner that have this installation, if we would like, let's say, to understand the impact of a dirty heat plate exchange, it means directly a higher consumption of fuel. So if we're heating a medium, because the gradient, it depends also how much capacity we heat. What is the volume that is required to be heated from one specific temperature to another temperature? It directly transforms to consumption of the energy, and it is directly impact the total cost of a factory for manufacturers, which is closely related with the margins that a refinery will make, a industry will make, or let's say any kind of industry. So it directly, yes, um, translate to money. What else we can tell about is that if you are tightening your bolts, it is better to apply some rust preventing paste, or let's say coating, because this coating will keep the moisture far from um, the bolts and from the threads itself, and will protect them for much longer. Also, very important thing is, let me go back to a image which shows the total stack of the plates, which is here. Also, your installation should have drain valves and vent valves. And this happen also for the reasons that you need to drain the media from the heat plate exchanger, and also while fill up, you have the vent open, so you will fill up the whole entire stack and remove the air from the unit. If you don't know something, you can ask me. If you have some questions also, you can ask me and drop it. Let's say, for example, yes, why we need the vents, why we need the drains. The vent and the drains also, they should be in proper functioning condition, because it is also the starting point of checking of what is happening in our unit. Is it filled? Is it not? And how we will test our unit, let's say later on, they play a really critical role. Also, very important thing to say is that when you are installing these kind of units um, for the first time, and you transport them, let's say in your factory, on your manufacturer, the designer should provide you also at the center of gravity of the equipment, so you can properly set your lifting tools and lift that equipment properly. Another thing that I would like to share with you, that The lifting also procedure will depend on what type of a heat plate exchanger do you have. That means that, and I will share with you an image, types will require a different attachment. You never lift a heat plate exchanger, small or bigger, from the plate stack. So you never attach any kind of, let's say, lifting equipment under the plates because they will be damaged. You never place and the lifting equipment between here and use the studs itself. I'd like the load to be distributed somewhere here on the plates. As you see here, this is the proper way of lifting, and it's the correct way to do such things. The transportation, the storage, and the set of the equipment, it's really, really important. I will share another image with you, another image which I have also referred here in the channel, and we have understand from the interaction with the equipment how much important is the ergonomy. The ergonomy plays a huge role, and everything should be checked. That's why it is not about doing the job, it is about doing the job properly, as required, as much as comfortable as possible, as much as safe as possible, and as much as better, let's say, for the equipment, for the people that are working. Because equipment and people should be interact in such way that they do not disturb each other. And why I'm telling that, why I'm telling that, the installation should be in such way that we have appropriate space. So this is the recommended space, because you have to take out the plates out there. You have to move. You have to have specific drain box. And very, very important is when we design something, we have design in such way that we have a specific, as you can see, it says installation aboard the ship when processing corrosive liquids. Because we can, we have seen many, many times, excuse me, seawater is draining from here, from this specific, let's say, equipment, and then all the piping is being corrosive. I have never understand why we do not use some stainless steel pipes so you avoid this kind of welding, fixing things. I really does not understand. There is such availability of different materials, but I also cannot imagine that making a drain just for your central coolers it costs that much, or setting, let's say, a pipe which is much much bigger, let's say 10 inch in diameter. It's not that much big deal for the shipping industry. But how the quality of work is being done is completely changed, because you have improved one of the small things by just doing it as it needed to be done and not as it is designed. Because the designer, he never overhauls, let's say, the coolers. He never do the job, the physical job. Okay, he knows how it should be, but he never do the job. You are the one who will do the job, and you are the one who will have the problem if the things are not designed properly. You will have the problems with the corrosion and all the things. That's why it's a very, very important thing that the designers take account the propositions of engineers, because the engineers are the one who are working the systems, who are able to optimize the systems and bring also that improvement on the ground and create much better vessels. And this is also the reason why I have created also many various projects and run them. And it's also available on the channel, which is the crude oil washing, which is also the project of banking optimization, the sludge optimization project. So I have run various of projects which really has a huge value for improving the industry, basically, because we work in such environment, we work for years, we work many hours. Why to not reduce the hours and make it much, much easier? Because we can do it. We can do it. And also, in my opinion, a lot of vessels are really, really understaffed from the capacity of work what is required. Because you do not have only the heat plate exchangers, you have various equipment, you have various of knowledge that is required to be applied. It is not just a simple thing, it is more than that, and that's why also we uh, taking the things step by step, deep dive, looking on them and share here on this channel. Uh, let me see if I can find something more interesting. One important thing that I would like also to share with you, it is that I have worked with different kind of coolers, heat plate exchangers, and also I have made also very let's say productive posts of which cooler are better, which designs are better. I have explained also the reason why they are better, how they improve the operations, and from the ones that are not performing well, what is the problems. So I have also make analyzing them each and every time for what reason and how to avoid this kind of problems, because I don't believe that we cannot solve the problems. We can solve the problems when we are discuss about them, when we change how we do things, how we build the vessels, and not just build just okay to say we have a heat plate exchanger, okay, and so what? You have a heat plate exchanger, but you are not able to do the maintenance properly. The people are tired, the people are taking, let's say, 10 to 15 days just service a heat plate exchanger. So this is not a, a proper design to do the things and work in such vessels. So that's why people are not happy to serve in that kind of vessels. We have to create environment that is actually working for people, working for equipment, and at the end, everyone is happy, let's say. One another thing that I would like to highlight in this today life is that it's very important. Excuse me, that we design additional elbows here. So what this means, by designing this kind of elbows and connections, we are much able, easy to disconnect them and to change any, let's say, corrosive plates that we have here. So we have small parts which is interchangeable, which is easier to move, much more lighter, and you are able to do, let's say, the connections much easier. If you compare, let's say, from some piping which is huge, they are for sure unmovable, and they can only move, let's say, in the dry dock. So let's see a little bit the main components once again. If you would like, let's say, to deep dive again in this session, or to create another video, you can write it, let's say, in the comments. You can write also here which kind of video you are preferring to hear, or you can let's say, lift a manual and ask, okay, we have this, we have that, what we can do. So we have described this one, and give also the attention to the details. So you can see, as we discussed at the beginning, each and every part has specific function. Okay, this is the reason why I'm making the video, that you have to remember that there is details and how these details affect and how the whole assembly together are performed in order to achieve a one goal at the end, which is the heat transfer of the liquid from one media to another. My dear friends, I have made almost 1,100 something videos on this channel. All of the materials are really great material. It is a motivational material. It is a breathtaking material that I have done through the years, yes, and from 2013, as I started, let's say, as third engineer until reaching chief engineer. I shared all my knowledge step by step from all these various ranks and services. And also in my latest, let's say, um, position as marine technical advisor in one of the biggest oil major companies, and now also as a CEO of marine optimization consultancy. I have created many projects. I have written down books as well. So I would like the only thing that you remember, it is not required to know everything. It is required to create a mindset that is moving from, um, let's say, I cannot do, from I can do it. Okay, this is the mindset that we are building here. It is not knowing everything, because no one knows everything. That is the truth. But is to create the mindset and the approach of learning new things, moving forward as you learn, and um, have this approach of continuous learning, seeing the things, have the interest, stay motivated, and just move forward to your goals. One thing that I would like to cover, because I would like to keep it full, I would like to share this tightening procedure. Let me show you. Yes, I would like to make this video much more complete, but if you like this video, write it also in the comments if you like it, and you would like also to share something more about it, some more details which you would like, let's say, to explore. I'm more than happy to create a additional video about that. So remember also in mind that for opening and for closing, there is also procedure. Okay, how you remove the bolts as well. So to give you an example, I will quickly give you an example, because yes, the video also, it gets too long. Probably will help you. This kind of coolers probably you will see, let's say, in huge installations in the vessels itself. So first of all, you remove these bolts here. You can remove them, and this you can see the step how it goes, and then you just do 1, 2, 3, 4 in the steps, and skimming of the pressure plates during opening must not exceed 10 millimeters by 2 runs per bolt, 2 turns per bolt across the width, and 25 millimeters 5 turns per bolt vertically. So basically what it says, if we have it vertically here, it should not do um, 10 millimeters like that, okay? 10 millimeters difference from one side to another, and also 25 millimeters, yes, vertically, like that. So, why it says like that? Because you can see vertically, it has much longer length, so it can be, let's say, bended 25 millimeters per 5 bolts turn. But from the side, as you can see, the length, the width is small. It cannot bend that much. That's why it gives you 10 millimeters difference. So have that in mind. Have that in mind. Let me show you also here that you can read it. So you can see it here. Okay. And it says that for to not break the plate, because it's huge pressure also from the release. If you are not going straight, you can damage the plate. Okay, you do it slowly, and slowly also you are close it, you are pressured. There's no rush. Make it slowly, make it straight. Use meters from one side and another internally as to measure the length, and do not hurry up, and everything will be fine. Thank you, my dear friends. Thank you for stay here in this channel with me. I really appreciate that, and I hope you will join some of the memberships that I have created through the years in different and various training courses about the advanced body systems with a lot of problems, a lot of real cases, a lot of things that will help you. Advanced course for um, purification, for the oily water separators, for an engine, for the diesel engines, for the crude oil washing if you are on the tanker. It is a completely guides and training sessions that will change your view of how you see the vessel and the system itself. And also I have done more than 123 videos about simulations, about different kinds of simulations, from starting the vessel from the dead ship to full away, running various problems also. And we have deep dive for all the existing systems of the vessels that actually you will able to meet them in any kind of vessels across the world. We have explored them all. So stay tuned. Stay tuned. More interesting videos will be uploaded. Stay tuned also in my LinkedIn channel, where I create a lot of posts each and every day, daily. You can follow also and set your notifications. Let me share my page. Excuse me. Let me share my page where I also share a lot of insights from the real life situations, what I have faced, what I have seen, what we are able, let's say, to improve in order to make our industry safer, creating also business opportunities. And let me see and let me share also what I have shared so far. I will share it with you. So here you can see that I'm sharing some things that I have seen in the industry, and it affects, let's say, the vessel timing, staying. This is a real life situations that I am describing. I'm sharing some projects. I'm also making some questions as well, running some votes. So I will run many votes, and you can participate there. Also, some gaps that I have seen in the industry. We have shared also the turbocharger And also I share yes, things about how the industry is working, how the business is working, how I see the business models itself, and how I see the engineers after years from the different view of point, um, how the best solutions are born. I share also my real life experience working for the big organizations, how you can achieve, let's say, working in innovative ways. And I share some things that I really, really like talking about. Also, what I have seen, also for fun. And yes, that is the things I have worked with, basically. This is what I share, what I have worked, what I have seen, what I have identified, and all the things I really believe that they play a huge role in the transition because in nowadays our industry, because it has much more a bigger availability of the tools as it is AI, we have more better to structure things. We have much more better way to focus on the things and from the tools that we're having. So I share all the things that, yes, I believe that can be improved and take, first of all, proactivity in all the things. So join the page, the energy, let's say, transition and the shipping change through discussion, through innovation, through collaboration as well, because the energy transition is not only one person game, it is the entire supply chain and entire people that are willing to improve the things and them to another level. But first of all, with humans and humanity in place, that we are basically creating a much better world, which is cleaner for the environment, first of all, for the people, and that it benefits everyone, not just one, but everyone. So we have a much, much safer environment to work in, and yes, everyone is benefit equally from that. This is the most important thing. Thank you very much. Thank you for joining today. I wish you a great evening and see you on another video. Bye bye.